Hi, third grade. Today we're going to get started on chapter 1. So would you please take out your math pages that you were given in your backpack? And I want you to turn to the second page, that is page 4. We are going to start on the vocabulary. So when we're doing math together, sometimes we'll do the whole lesson and then sometimes we'll do parts of the lesson and we'll skip around the pages and the numbers. And that's okay. If we skip some things, just pay attention to where I am in the book so it's easy for you to follow along. You can always press pause and go back if you need something repeated. So I'll just record the lesson and you can follow along at your own pace. So we're going to start with vocabulary, something in math that is so important that we know is all of the different math vocabulary. Those are math words. So here we have a Venn diagram. And on the left, we have addition words. On the right, we have subtraction words. And then in the middle are the words that would be for addition and subtraction. The directions say, sort the review words with a check into the Venn diagram. So we're looking over here in this yellow box where it says review words, and we're focusing on the ones with a check. The first one with a check says add. Would add go under addition or subtraction? If you're thinking addition, you're right. When we do addition, we are adding numbers together. So let's write the word add under addition. Then we can cross it off. Okay, the next word is difference. When we find the difference of a problem, we are doing subtraction. So the difference is the answer to a subtraction problem. Here's an example. 5 minus 3 equals 2. Well, 2 is the difference. That's what we call it. So that would be a subtraction word. Okay, next word with a check mark is hundreds. When we use the word hundreds, we're talking about place value. Ones, tens, hundreds, thousands. Do you think that hundreds is a word we could use for addition, subtraction, or both? Can we add numbers in the hundreds? Yes. Can we subtract numbers in the hundreds? Also yes. So the word hundreds would go under both. That goes in the middle. Okay, next word is ones. Okay. Can we subtract numbers in the ones place? Yes. Can we add numbers in the ones place? Also yes. The word ones also would go in the middle. Okay, next word, regroup. When we have to regroup, it means that we don't have enough in a column in the ones, tens, or hundreds, or we have too much. So can we regroup with adding and subtracting? Yes. The word regroup would also go in the middle. Remember, if I'm going too fast, press pause on the video, catch up in your workbook, and when you're ready, press play. Okay, our next word is subtract. Well, if we subtract, we know we're doing subtraction, so that would be a subtraction word. Next word is sum. When you are adding, you're finding the sum. Let's do an example over here. 3 plus 2 equals 5. Well, the answer to an addition problem is called the sum. So if we said find the sum, you would know that you needed to add. So that is an addition word. And the last word is tens. When we can add tens and we can also subtract tens, just like we talked about with ones and hundreds. So tens would be a word that we would use for both addition and subtraction. Okay, let's move on. And this next section of vocabulary are words that we are going to use this chapter and this year. So some of these words you may have not heard before, and that's okay because we're going to learn about them. So the instructions say, complete the sentences by using the preview words. And preview means words that we haven't seen, but we're just viewing them before we really learn about them. So if you don't know these, that's okay. Let's start with number 1. A number close to an exact number is called an. So that is this word here. I want you to circle it. An estimate. So say that with me, estimate. When you estimate, you are making an educated guess to what a number is. It's not exactly the number, but it is close. And we are going to be using that word a lot in the next few days, next week. Oh, you know what? I made a mistake. I always make mistakes. So actually erase that word, estimate. Sorry, 3rd grade. Okay, we'll try that again. A number close to an exact number, you can estimate to find that number, which is, we'll talk about in 1 second. But a number close to an exact number is what we call compatible numbers. Compatible numbers are numbers that are very close to each other, but they're not the same. So the number 10 and the number 12 could be compatible numbers. They're close to each other, but they're not the same. So the number 5 and the number 45 would not be compatible numbers because those numbers are too far apart from each other. So 2 numbers that are close to each other are compatible numbers. So that is our answer for number 1. So sorry I made you write estimate, but that's okay. Okay, press pause if you need to catch up with writing. Okay, number 2, you can blank a number to the nearest 10 or the nearest 100 to find a number that tells about how much or about how many. This is the word estimate. When we estimate, we're making an educated guess of how many there are. So here's an example. We have 21 students in our class. We have exactly 21. That includes the kids at home and the students in the building. So somebody could say, well, I think Miss Canzanetti has about 20 students in her class. And they would be right. We don't have 20, we have 21, but 20 would be a good estimation of how many students are in the class. So that is the word estimate. It's almost like another word for guessing, but an educated guess. Okay, moving on. Okay. We're going to skip to number 4 because we're going to talk about this one today. The blank states that you can add 2 or more numbers in any order and get the same sum. Okay, this is called the commutative property of addition. Let's say that again. Commutative, I'm looking right here. Commutative property of addition. And it means that I can take any numbers and put them in any order and get the same sum. So let's do an example here. 10 plus 4 equals 14. I could switch these two. I could switch these two numbers and get the same answer. 4 plus 10 is also going to equal 14. That is called the commutative property of addition because the word commute means to move back and forth. So we could take those two, the numbers 10 and 4, and put them in any order, and we'll get the same answer. So that is our answer for number 4. It's a long one. The commutative property of addition. Okay, let's move on. So I want you to flip through your pages until we get to page 3. Okay, there it is. All right. So we are on lesson 1.1, and lesson 1.1 is all about number patterns. We are going to skip a lot of these first problems here that are talking about the 100s chart, and that's okay. So let's just start here with the definition of a pattern. So follow along. A pattern is an ordered set of numbers or objects. The order helps you predict what will come next. So if I said to you, yellow, green, yellow, green, yellow, green, you would know to say green because I already started a pattern. Here's another pattern. 10, 20, 30, 40, 50. You would say 60 because you've already figured out the pattern I'm saying is counting by tens. Other patterns can be simpler as just counting by ones. If I said, okay, say the number I'm not saying, 1, 2, 3, 4, 5, 6, you would know to say 7 because I'm counting by ones, and that is still a pattern. So you can have patterns with colors, patterns with shapes, patterns with objects. For math, we're really going to be talking about patterns that we see with numbers. We'll do that today, and then as we go forward with multiplication and division, there are even more patterns, and these patterns help us understand math in a better way. So we're going to actually skip this whole page. And I want you to go to the bottom of page 6. The bottom of page 6. And right here. Okay, we're going to start down here at the bottom. So what we need to do here is think of two numbers that when we add them together, we get the answer 6. So let's see, we could do 4 and 2. We're going to be talking about evens and odds. If the number 4 is an even number, and the number 2 is also an even number, we get an even number as our answer. Okay. Let's let's move on to this one. What two numbers can we add together to get 7? We could do 4 and 3. Well, 4 is an even number, and 3 is an odd number, and we get an odd number. Let's do one for number 8. We could do 5 and 3. 5 is an odd number, 3 is an odd number, and we get an even. So here's another pattern in math. Two evens, an even plus an even equals an even. An even plus an odd equals an odd, and an odd number plus an odd number equals an even number. Okay, I want you to turn your page, and we are on, now we're on page 8. Page 7 at the top. All right, let's read the directions. Complete the addition sentences to show the commutative property of addition. Remember, the commutative property says you can take any numbers that you're adding together, put them in any order, and get the same sum or the same answer. So we have 3 plus blank equals blank and 4 plus blank equals blank. Well, we need to use the same add-ins. So we know we need to use 3 and 4. So we're going to plug in 4 over here. 3 plus 4. 3 plus 4 is 4, 5, 6, 7. So if we know that 3 plus 4 is 7, we know that 4 plus 3 is also going to be what? 7. Changing the order of the numbers doesn't change our answer. Let's move on to this next section. You're going to be doing the same thing. Oh, and we need to say, okay, find the sum. Remember, sum means we're adding. Then use the commutative property of addition to write the related addition sentence. So starting with number 2, 8 plus 5 equals, find the sum on your own. If you said 13, you are correct. Now we're going to take this addition sentence and we're going to do it again down here, but now we are changing the order of the numbers. So is 8 going to come first? No. Now it will be 5. 5 plus 8. What is our answer going to stay the same? Yes, because of the commutative property of addition. Okay, number 3. 7 plus 9. 7 plus 9. Take 10 seconds and answer that on your own. If you said 16, you are correct. Now we take our add-ins and we are going to flip-flop them. So now we have 9 plus 7. Our answer stays the same. Okay, I want you to do number 4 on your own. Okay, you should have gotten 14. And you should flip the add-ins. 4 plus 10 is 14. Moving on. For numbers 5, 6, and 7, is the sum even or odd? Write even or odd. So 8 plus 1 is 9. Is 9 an even number or an odd number? If you said odd, you are correct. 3 plus 9. Well, 3 is an odd number and 9 is an odd number. Do you remember the pattern? An odd plus an odd equals an even. So let's see, 9 plus 3 is 12. Well, 12 is an even number. Number 7, 4 plus 8. Well, 4 is an even number, 8 is an even number, and even plus an even equals an even. And are we right? Is 4 plus 8 even? 8, 9, 10, 11, 12. Yes, 12 is an even number. All right, now we're going to skip to number 10. Number 10. Select the numbers of sentences that show the commutative property of addition. Mark all that apply. When you see mark all that apply, it means that there's more than one answer. What are we looking for? We're looking for the number sentences that show the commutative property of addition, meaning we can take our two numbers, put them in any order, and get the same answer. All right, let's go through this all together. Looking at A, 27 plus 4 equals 31. That's true, but is that showing that you can put those two numbers in a different order and get the same answer? No, it's just a typical number sentence. That's not showing the commutative property of addition, so cross it out. Let's move on to B. 27 plus 4 equals 4 plus 27. Well, what's first on this side? 27 and 4. Okay, and then on this side is 4 and 27. Are they taking add-ins and putting them in a different order? Yes. 27 plus 4 equals 31. And 4 plus 27 also equals 31. So is this showing the property of the communication? Yes. So we are going to circle in that one. Let's look at C. 27 plus 0 equals 0 plus 27. If you're thinking yes, you are correct. Because they are just putting these in a different order. And let's look at D. 27 plus 4 plus 0 equals 27 plus 4 plus 0. Well, let's look at this side of the equal sign. 27 for 0. Now let's look at this side. 27 for 0. These three numbers are all in the same order. The order did not change. So this is not showing the commutative property of addition. Okay. That's where we're going to stop for today. So now I want you to do your math homework. The link is on Google Classroom. Click on the link, and your username is your 9 number, and so is your password. Hey, third grade, thank you, and let me know if you have any questions. Okay, bye.